Welcome, everybody, to Astronomy. Hopefully, everybody will make it to school at some point this year, which means that this virus thing is starting to go away. When you do, head to room 3104. That is the astronomy room at DP. So that's my room, 3104. Hopefully, everybody will make it there. If not, it's going to be an interesting year. We'll get through it. But we're going to see how this goes with me recording over the PowerPoints, almost as if I was teaching you, but it's just being recorded. So we're doing this one at my house. I may be doing some of them at school. Who knows? Yeah, my name is Mr. Hyatt. Welcome. I know that I look like a walrus right now I have a driver's license photo coming up in about a week, which means I would like to have this on my driver's license photo. So I've been growing it out since quarantine started back in March, and I'll finally be able to shave in a couple weeks. So anyways, welcome to Astronomy. Today you are going to need a pencil, obviously your computer, and a piece of paper, and hopefully you have access to our Canvas course. Hopefully. Let's move that down just a little bit. There we go. All right, so first things first. I need to find my mouse. There it is. We are going to head to Canvas. Hopefully you guys can get into Canvas. When you get to Canvas, you're going to see this. So what I'm actually going to do is do like a little web browser. This is our home page. You can see that I've got a few puppies, which I'm going to talk about nonstop. So they're on our homepage. To get started every day, you're going to head to Canvas. You're going to head over here to where it says modules. Click that. But first, how do you contact me? My email is right here, and phone number that goes to classroom phone is right here. Email is by far the easiest, most efficient way to get a hold of me. Our syllabus, which we are going to go over tomorrow, is linked here. Every PowerPoint that we do in class is going to be here. So the PowerPoint that we're doing today, actually, I'll just show you. If you go to the first 9 weeks, boom, there it is. First day's PowerPoint. So we have, you have the ability to go to any PowerPoint that you need. And this is for new students. Let's say you transfer in halfway through the first 9 weeks. That's what this is for. So let's go over to modules. Every class does it differently. What I found works best is I just do it by week. So marking period 1, week 1, is going to be right here. You're going to have Monday, Tuesday, Wednesday, Thursday, Friday. Marking period 1, week 2, Monday, Tuesday, Wednesday, Thursday, Friday, etc., etc. So obviously today is Monday, week 1, day 1. We're going to click right there. And the first thing that you're going to see is bell work. So every day we're going to have bell work. Every single day, you guys are going to get points for bell work. It gives me kind of a few minutes to take attendance, to set things up for labs, and it's a way for you guys to earn points. So you're going to click on today's bell work. You're going to get points for it. So this is the first thing that you're doing in class, and you're already earning points. When you click on bell work, you guys are going to see this. You're going to have, obviously, your name, first name, last name, what class period you're in, and then your student number. Make sure that you enter your student number correctly. That's how the computer actually adds up all your points and puts that into progress book. So make sure that your student number, you can misspell your name if you want, but student number, that's the important one. And your bell work for today is to write 2 sentences about what you think this photograph is. So if we go back to PowerPoint, click on Monday, go to bell work, pay attention to your student ID number. If that does not work, if you cannot get into Canvas, you can still earn points for bell work today. What you're going to do is open up a new browser, and I have a website. I don't use it as much now that we have Canvas going, but we used to use it every day in here. If you type in mrhyatt.rocks, mrhyatt.rocks is the web address. Click on This Week in Astronomy, and this is going to change each week. You're going to go to what we're doing this week. You have Monday. You can actually look ahead and see what we're doing the rest of this week. For Monday, your bell work is right here. So if you click that, that will take you to the exact same place that the link in Canvas does. And that's just a web page. It's not through Canvas, so anybody can get there, even if you do not have Canvas access yet. So answer that question. Pause this video. And I will pick it up when you guys are done answering that question. And back, hopefully. So you've done bell work. What is next? Let's just go to the PowerPoint. And if I'm looking up, because I have a screen up here that is mirroring what you guys are saying. So, all right. So, picture of the day. There it is. Tell me what you think that photograph is. Hopefully you've already answered that, because I'm going to tell you what this photograph is. There it is. That's a lot of reading. So the blue, this is a nebula, which is a bunch of gas up in space. There's different types of nebulas, which we'll learn about this year. This is a shock wave, most likely from a supernova, that's sending a shock wave out through this gas. And as this shock wave is traveling through this gas, the gas is heating up, and so it's becoming visible. So that's what we are seeing. You heat gas up, strips off the electrons, it becomes ionized, starts to glow in the visible spectrum. Anyway, the red is hydrogen, blue is oxygen. There's a lot of oxygen up in space. All right, next. Now, I would like you guys to brainstorm. Come up with some things in your mind, write these down in your piece of paper, that you think that would be considered celestial objects that you have seen with your own eyes. Just 5, 10, 100, however many you guys think. And then you guys are going to head back to Canvas. You're going to click on Padlet. I'm sure that you have used this before. What celestial objects have you guys seen with your own eyes? Go ahead and write something in. All right. I'm going to leave this up all day, which means you're going to see a bunch of other people's answers. Try to come up with some that, are your own thoughts. Moving on, after you've spent a few moments doing that, you can pause this video again. We're going to take a quiz. This is what your piece of paper is for. So after each question, take about 60 seconds. Normally we would be doing this in class. Take about 60 seconds and pause the video to write down your answers on a piece of paper. This is not graded, obviously. We're doing this at home. I just want to see how well you guys can do. All right, so first question. This is tough. First question. Draw a triangle. It's all the instructions that you get. Pause it. When you're done drawing a triangle, you're done answering question 1. Unpause. And we can go to question 2. All right, question 2. Try to do this. Without using a calculator, quickly find the sum of the first 100 integers. So 1, 2, 3, 4, 5, 6, 7. Those are the integers. So try to add 1 plus 2 plus 3 plus 4 all the way up to 98 plus 99 plus 100. Try to do that without using a calculator in 60 seconds. If you don't think you can, make an educated guess, set your pencil down. Don't use a calculator. Don't Google it. Again, this is not graded. All right, so pause, 60 seconds. Good luck. Go. And now question number 3. I'm just going to let you guys read that. I'm going to move my face out of the way. And I will let you guys read that. You have 60 seconds. And hopefully you are done with question 3 now as well. So let's go over the answers. Here we go. Question number 1. Draw a triangle. Hopefully you guys were all able to do this in less than 60 seconds. There's a lot of different triangles though. So your triangle on your sheet may look different than somebody else's. Both of you would be correct. And I want you guys to remember that this year. Your answers may look different than somebody else's, but it does not mean that yours are right and theirs are wrong. There's different ways to answer a lot of these questions. There are some questions, 2 plus 2, where there is a correct answer, there's a wrong answer. But a lot of times you're going to find that your answer is correct as long as you can back it up, even if it's different than what somebody else is saying. All right, question 2 is seeing if you can add up 1 plus 2 plus 3 plus all the way up to 100. Over the last 5 years of doing this, I've had maybe 10 people get this. So it can be done. The key is to not do 1 plus 2 plus 3 plus 4. There's very few people in the world that can do that. The key is to find some trick, to think outside of the box. And there's a lot of times this year where that's going to be required, to think outside of the box. So how would we do that? Well, 1 plus 2 plus 3. If you take the first integer, 1, and the last one, 100, and add those together, hopefully everybody can do that, you would get 101. If you take 2 plus 99, 101. 3 plus 98, 101. How many times would you have to do that? Well, how many pairs are in 100? There's 50 pairs. So 50 times 101, some of you might be able to do that in your head, but hopefully we can all do that in less than 60 seconds. Scratch that down on a piece of paper real quick, and the answer is 5,050. So if you think outside of the box and don't just try to add 1 plus 2 plus 3, this problem is definitely solvable in less than 60 seconds. And number 3, this giant, ridiculous paragraph. There's going to be plenty of times this year where you have a lot of information, and the key to answering a question or to figuring out what is being asked of you is to figure out what information you need and being able to pull that out. So without reading all of that, what I'm going to do is just cross out what you don't need. And the things that you do need are now in bold. So let's write all of these down. You need, well, let's first find out with the question. How far apart do these poles need to be? All right, so the poles are 10 meters long. You have to sink each one down a meter into the ground, which means they are going to be standing 9 feet off the ground. The cable is 18 meters, and it has to touch the ground. How far apart do they need to be? That's all of the information that you need. All right, so if each pole, let me move my face again. That's not my face. If each pole is 9 meters tall and the cable is 18 meters long, well, that means that it goes down 9 meters and back up 9 meters. That means that the poles have to be right next to each other in order for this to work. In order for this cable to touch the ground, they need to be right next to each other. It's kind of a stupid question, but the key is to see if you guys can figure out which pieces of information you needed. And that's going to be definitely something you need to be able to do this year in astronomy. All right, moving on. My goals for you. What do I want you guys to get out of this class this year? All right. Number 1. Let's move my face again. I want you guys to know the big ideas in astronomy. If you don't remember the diameter of Jupiter, I'm fine with that. If you don't remember the, you know, temperature of a blue giant star, that's okay. What I want you to know is that Jupiter is a gas giant that's very far away. I want you to know that a blue giant star is very hot and doesn't live for a long time. I want you to know the big ideas in astronomy, so that if somebody comes up and says something, you can talk intelligently about it. You know something about what they are saying. So that's goal number one. Don't remember every little detail. Remember the big ideas. Goal number two that I have for you guys. Actually, let's back up. This is why I want you guys to be able to speak intelligently. There's a lot of things that people think about astronomy that are misconceptions. So let's go over these. Number one, these are the top 10 misconceptions in astronomy. Number one, what goes up must come down. A lot of people think that. You throw a baseball in the air, comes back down. Airplane goes up, airplane is eventually going to come back down. However, if you blast off, if you get going fast enough and you can escape Earth's gravity well, you don't come back down. There's plenty of satellites and rockets that we have blasted off fast enough so that they're not in Earth's gravity well anymore, and they're not going to come back down. So the whole what goes up must come down thing is true most of the time, but if you can reach escape velocity and get going fast enough, you're going to escape Earth's gravity and you do not come back down. You just keep driving away. Number two, the sun is a yellow star. That's kind of a trick question. It's classified as a yellow star, but it is not yellow in color. Most people think that it's yellow in color because they can only see it during a sunrise or sunset when it's traveling through a whole bunch of our atmosphere and a lot of light rays are being scattered out. If you actually look at the sun, don't do this. Please don't do this. But if you look at the sun, it's actually white. And if you take every wavelength of visible light, combine them together, you get white. So our star is actually a white star. If you go up into space, our sun is white. When you see it yellow, that means that there's some light that's being filtered out, whether through the camera or video lens or through our atmosphere. It turns out that our sun is actually white. Weightless astronauts have left Earth's gravity. This kind of is related to that first one. A weightless astronaut actually is not out of our gravity. Otherwise, they'd float away. They would not continue to orbit around Earth. A weightless astronaut is actually falling around the edge of Earth. A weightless astronaut is moving forward about 17,000 miles an hour. So as they are falling, they continue to fall around the curve of planet Earth. Earth is still pulling them back in. So they're definitely not out of gravity. They're simply in free fall. North Star is the brightest star in the night sky. It's actually like 10th. North Star is famous because it's directly north. But Sirius is actually the brightest star in the night sky. On a dark night, you can see millions of stars. That is true if you have a pretty good telescope and it is completely clear. The number of stars that you can see with just your eyes, with no telescope or binoculars or anything, 4,000, 5,000, if you have really good eyesight. So there are millions, billions, trillions of stars out there. We can't see most of them. Total solar eclipses are rare. In any spot on Earth, they're rare. So if you went into your backyard and just waited for one to happen, you could wait 1,000 years. However, a total solar eclipse is going to happen somewhere on planet Earth about every year and a half. So they actually happen more frequently than the Olympics. And not a whole lot of people would say something like the Olympics are a very rare thing. You just have to be in the right place in order to see a solar eclipse. Days get long in the summer and short in the winter. A lot of people think that. However, the longest day of the year is actually the first day of summer, which means the second day of summer is a little bit shorter. The third day of summer is a little bit shorter. And the fourth day of Summer is a little bit shorter. As summer moves on, days are actually getting shorter. And the shortest day of the year, it's called the winter solstice, is the first day of winter. So the second day of winter is a little bit longer, and the third day of winter is a little bit longer. So it's actually the days are getting shorter in the summer. They're getting longer in the winter. A couple more. At high noon, the sun is directly overhead. That is true if you are standing directly on the equator. Anywhere else on planet Earth, and the sun is not going to be directly overhead. And that's because the Earth is tilted. And we'll go over that plenty in the next couple weeks. The sun rises in the east and sets in the west. These two are related. That's true in very specific places on Earth, depending on what time of year it is. Most of the time, it's going to be like northeast, southeast, northwest, southwest. It's never, very rarely, going to be directly to the east or directly to the west. And finally, the moon comes out only at night. The moon comes out in the daytime as well. You don't see it or notice it as much because when it's daylight, it's not the brightest thing in the sky. But this, I'm sure you guys have seen it. The moon is definitely visible plenty of times during the daylight. All right, so going back to my goals for you, those are the things where people say, those misconceptions, people talk about those all the time. After this class, hopefully you'll be able to explain why those are misconceptions. I want you guys to know about how science is done as well. This is a big one for me. There's a lot of anti-science going around right now. There's a lot of Earth is flat. There's a lot of vaccines are bad. There's a lot of climate change isn't real. I want you guys to know how science is done and what makes good science and what makes bad science. I almost think that this point is more important than just the astronomy thing. I want you guys to know how the scientific method works, why scientists often get different answers. I want you guys to know what pseudoscience is, the whole flat Earth, Bigfoot. I want you guys to know about careers in science in case you guys are interested in being a scientist. This is what I think is my most important thing in teaching this class. And then finally, I want to encourage you guys to have positive attitudes towards astronomy and science in general, so that in 10 years, if I see you at Publix, you're like, oh, I just read this, about astronomy because I'm still interested in it. I still want to know about how science is done. I want you guys to be a lifelong learner in science, astronomy specifically, because I enjoy that. But I want you guys to want to better yourself, to want to become educated. And so my goal this year is to help you be excited about science. With all of that said, I do want you to know that this is an honors class, which means it's basically a college level class. If it was up to me, I feel like it should be an AP class and you should get college credit for it. But there's no AP test, which means we can't have it as an AP class. It's just an honors class. The textbook that the county bought for this class is a college textbook. The things that you are going to learn are the same things that you would learn in a college introductory astronomy class. The difference is that in college, it's half a year long and you guys have an entire year to go through everything. But there's a lot that we're going to cover. We're going to go quickly. We have to cover the entire universe. So just keep that in mind. There are, some things that I want you guys to know about this class before we go too far. First, college level, college textbook. I'll show you guys where the college textbooks that we use are in just a moment. Actually, I can do that right now. So if you go back to MrHyatt.rocks, you did bell work. Right here are our textbooks. And you can open those up. It's going to take a while to load. Should have done this before. But here we go. College level textbook. And you can just go there and pick a page to read. This is the one that the county bought. Astronomy Today. It's college level. So that's something that you guys need to be aware of. We have a lot of standards that you guys are going to need to know. There's over 50 that we have to cover this year. In standards, you could have one of them in an entire unit. So we're going to be going quickly. There's over 100 learning goals. Those are the what should you know and be able to do by the end of this year. And there they are. I can print these out for you if you'd like, but this is all the stuff that it is my job to teach you guys, and it is your job to learn to be able to do by the end of this year. We do a bunch of homework. In order to get through all of this, we have to go quickly, which means I don't have time to do all of that in class, especially with distance learning. So there's going to be a lot of things that you guys are going to be responsible to do outside of class. I don't like giving a whole lot of homework, but the reality is, with this being an honors class, with so many standards, you guys are going to have stuff to do. I try to give class time if we're face to face. I try to give class time for almost every assignment so that if you have questions, you can come up and ask. But very rarely are you going to have enough time to finish everything in class. Some people do, but a lot of people don't. We do college level labs. Many of the labs were written for college students, which means it's given to you, and it's the only way to get through it is to read the instructions. It's not one of those labs where the teacher goes through and says, okay, now you do this, and then you do this, and I show you, and you just copy me. You need to read the instructions. The instructions lay everything out, and it's up to you to figure out, okay, what do I need to do now? What do I need to record? What do I need to look at? Let's see where my mouse went. There it is. We do talk about constellations. A lot of people sign up for astronomy class wanting to talk about constellations. We talk for about half a day, sometime next week. We don't really learn constellations. We don't really learn, about the signs of the zodiac or astrology. We're learning how the universe works. We're learning planets. We're learning galaxies. We're learning stars. So we learn about constellations because they are useful, but we don't spend a lot of time on it. And the last thing that you guys need to know, we use college level math. I've tried over the last couple of years to ease away from this as much as I can, but there are some things that we just can't get away from. Astronomy, when you get to college, is part of the physics department. It's all math. So some of the equations that you are going to see this year are popping up on the screen right now. Are you going to be required to solve every one of these? No. You are going to be required to understand what they are and what a professional astronomer would use each one of these for. Some of them you will need. Black body radiation, you do need to know Hubble's law. We're going to do an entire lab where you actually derive this. E equals mc squared, probably the most famous. You guys are going to have to know exactly what E, M, and C mean and how that relates to astronomy. So there's a lot of this stuff that you guys are going to be seeing this year. And I want you guys to be aware of that and know that on day one. Okay? So something to look forward to. Yeah. College level math in high school. There we go. What do you guys need to bring each day? Obviously, something to write with, a pen or a pencil, a composition notebook. We are going to be recording, taking notes, doing labs, gluing stuff in. If you use a spiral notebook, those little perforated, things so that you can rip them out, your notebook's going to fall apart. So a composition notebook is one of those, ones that many of them are black and white. They look like this, and the pages do not come out. So we're going to use a science journal this year. It needs to be a composition notebook. If you get a composition notebook by the end of this week, you will get extra credit points. And there's a little assignment so that you can take a photograph of you holding your composition notebook. And if you do that, you will get extra credit points. Obviously, you need your computer, you need headphones. There's going to be some times where we are watching Edpuzzle videos. If everybody has the sound on, nobody can understand anything. So you do need headphones in class, preferably the kind that plug in, Bluetooth doesn't work on your computers. So plug in headphones. And when I say, all right, guys, take out your headphones, obviously take out your headphones. Otherwise, you shouldn't have them, especially if you're in face-to-face. So by Friday, X credit, if you have a composition notebook, and take a picture of it and put it on Canvas. I'll show you that in a sec. Your first homework is to do an Ed puzzle. The video is called The Teenage Brain Explained, and it kind of goes through why you guys are the way that you are. That sounds kind of bad coming from an older guy, but why are teenagers always tired in the morning? Why, are you more interested in friends than school? So this goes through some of that stuff, just so that you guys kind of have an idea of the way that you are. This is going to be due tonight, so you have the rest of class period today to work on this. But this is going to be due tonight before you guys go to bed. It's due at midnight. A lot of times when things are due, they're going to be due at 11:59. And let's see if we go back to Canvas. It closed my browser, so bear with me. Here we go. So we have acquire a science journal. How do you get points for that? You get a science journal, write your name on it, hold it up next to your face, and take a photo, and you can submit it. Submit that little photo. Ed puzzle. There you go. You can open that, click on that button, and there is your Ed puzzle. So this is the teacher's view. Yours is going to open up like that. What else do we have? Here is our PowerPoint, what I just went over, slide by slide. If you want to go over it, you're welcome to. You can download it. So if you click there, downloads to your computer, and you've got the PowerPoint. If you guys have questions, email is the best way to get a hold of me, and I will do my best to get back to you as soon as possible. I believe that's the last slide. Yeah, so click on modules, head over and start watching your video. If you've got a science journal, a composition notebook already, you can get X credit on the first day. And that's day number 1.